student, in section 2.5, we're talking about differentiation. It's all about how different ways of differentiating. So I'm gonna do it by topic. The first thing I want to bring to your attention is notation. So I did start by introducing the prime symbol for the derivative. So you have f prime x. We know that this is the limit as h approaches 0, given our function f of x plus h minus f of x all over h. So that's just the formula that we've been using and I introduced to you recently. So as far as notation, we're talking about the derivative. And so I want you to remember that all of the following are ways we represent the derivative. So the first one, obviously, f prime x. This is also equivalent to y prime. This is also equivalent to dy over dx. This is also written as d over dx of f of x. So this is probably new to you. You probably haven't seen that notation in a while. And all of these that you see present here are ways that we express the derivative of x. Okay, so that's just notation to bring you aware or make you aware. So we're going to start with the constant function and the way we notate that. And I'm going to show you all 4 ways. And so as we're taking notes, let me know where you are. Are you at notation?
Yeah.
Are you about there? Okay. So I am. So we have the constant function, which, as you guys have heard me express, when we differentiate that, we basically count it as a 0 because it's basically that number times a variable of some sort, typically x to the 0 power, which when we differentiate, it goes away basically. So if, as a notation, if y equals f of x, and this is equal to c, some constant, then the derivative, so we can express it as such, is equal to 0, the first derivative. Obviously the first derivative is 0, the second derivative also is 0, and so on. So we can notate that the first derivative at y prime, is also equal to 0, which is the same as dy over dx, and that's equal to 0. You remember the example I gave you when I said to you, okay, what if I have 3x squared plus 2, and that was your displacement function, right? And I said to you, okay, well then the first derivative, without doing all that 4-step process of using the function, is simply 6x. Right? You remember that? Yeah. All right, so that means that this 2 that's sitting here, we counted as 2x to the 0. So if you think of the math, 0 times 2 is 0, and bye-bye, it doesn't matter if I subtract 1 or not, it's still 0, right? So anytime you have the constant, that will end up being 0. And so graphically speaking, if you're looking at the diagram, obviously if this is your xy plane, and you have a line, let's say hypothetically at y is 2, just as an example, that means that this represents f of x, which is a constant. You will also notice that the other connection is the slope itself. Because it's a horizontal line, the slope is equal to 0. So that's another leading factor that should help you with that. So bringing some examples to you, are you good in the notes so far? Is anybody lost? So far, so good? Yeah? All right. If I were to say to you, example 1 had the following practice questions. So what the question stem here is basically we're differentiating constant, that's all we're going to do, constant functions in this particular example. All right, and so if I have this, then the question stem that you're going to look out for is find the first derivative, f prime x, for f of x, and that is equal to 3. And so the solution for this is quite simple. It's simply, so I'm just going to write here solution. And you want to use a notation, so please pay attention. So the f prime x is equal to 0 is what you would answer. The other notation, very simple, similar in concept. If I said to you, find y prime for y equals negative 1.4, you would still, in this case, say your solution is y prime equals 0. Right, so it's nothing difficult, right? I assume. If they instead said to you, find dy over dx for y equal to pi, you would simply state dy over dx is equal to 0. Again, another constant. And lastly, the last example that I'm just going to show you the notation, you would say find, in the question stem, find d over dx for 23, as in the number 23. Notice in this answer you would say d over dx 23 is equal to 0. And that's how simple the constant is. It's just a notation which may throw you off. So I've shown you the power rule already, which is theorem 2, and I do want to show that to you next. Just waiting for everybody to catch up. Is there anybody who needs a minute? Okay. Moving on. All right, theorem 2. So theorem 2 in this chapter refers to the power rule. And I've already shown you that. So the notes for this are if y equals f of x, and that is equal to x to the n, where n is a real number, then in theory, or in application, what we have here then is the first derivative of x by notation is the constant, or the exponent times the constant, and the exponent take away 1, which I've shown you already. It's the same thing for whether it's y prime or dy over dx or d over dy, same thing. So this was the example that I have given you in the past. Say I have 4x to the 5th, for example. Then what this indicates is that I'm going to multiply 5 times 4, and I'm going to then say x, and this will become 5 minus 1. That's the thought, with this being times, obviously. So this exponent value, or this first derivative, is actually 20x to the 4th. That's the f prime x or y prime or d over dx and whatever. So that's the connection between the two. So they do give us some examples. In example 2, if I could show you real quick, let's see. Here's example 2. So we are basically differentiating power functions. And I do have a really good application question to share with you that we'll put it all together at the end. So hang tight for that one. So in the question stem that I want you to pay attention to, it says find the first derivative, so f prime x, for f of x, where that is equal to x to the fifth. And so again, we simply multiply the, in this case I give you just x to the fifth, so it's basically 5 times the x, and that is raised to the 5 minus 1. Final answer for this would be that the first derivative for this simple power function is 5x to the fourth. Capiche? So far so good? Okay, and the other question stems are very similar. I just want to expose you to them so they're not new to you. So if it says find y prime for y equal to x to the 25th power, then your result for this would be what? Tell me.
25x to the power of 24.
Yeah, 25x to the power of 24. So it's always multiply and then take away an exponent. And that's with coefficient 1. If that were a coefficient, instead this were to say, by the way, if this were to say 2x to the 25th, your answer would have been?
50x to the 24th.
Yeah, y prime is 50x to the 24th. So that's the simplest way I can explain differentiation of a simple power. In part C, they have another question stem that I want to expose you to, which is find dy over dx for y equal to t to the negative 3 power. What do you think this one's going to be? So this will be dy over dx. Now remember, you're going to multiply first. So you're going to start with negative 3t, and then you're going to take away 1, which is negative 4. You can re-express this if you needed to, because we usually don't like negative exponents. So you could technically say negative 3 over t to the positive 4. Just a thought. Okay, part D, another example, very simple. It says find d over dx given x to the 5/3. So it might be confusing because it looks like those two are attached, but they're not. Okay, so when you answer that question, your solution is going to become d over dx is equal to 5 over 3 x to the 2/3. Remember, we subtract an exponent. So let me show you real quick. The coefficient, which is 1, is in red, right? Here's the x. Here's your 5/3. So the first thing you're going to do is you're going to multiply these two. That's where this comes from. And then we're taking away 1. So I'm taking away minus 1, which is the same as 3 over 3, which in theory is 2 over 3. That's it. All right? All right. So if that's cool for you, let's try example 3. And if you have questions, just holler. So in example 3, we're also differentiating. Power functions. Shocker. Okay, so we're differentiating, and I'm going to start with part A, and I'm going to ask you to solve for this. Tell me, if I ask you to find the first derivative for x, for f of x equal to 1 over x to the 4th, what do you think your steps are going to look like? Okay, so your first step should be to bring this up. So this is really x to the -4, correct?
Yes.
Now we're going to apply the power function. So technically there's a 1 here. So -4 times 1, that's -4 x. I'm going to take another 1 away, which is going to put me at -5. And then if I want to correct this, this is technically -4 over x to the 5th power. Is that easy? You want another one?
Yeah.
One more like this? Okay, so let's make this over here. I'm going to write it in blue. So I'm going to ask you, we're not doing this one, we're going to do 1 over, say, x to the, I don't know, 6th power. So what do you think that's going to become?
X to the -6, which then becomes -6x to -7.
So -6x to the -7, which I can re-express as -6 over x to the 7th. It's a pattern. Once you know the pattern, you're right as rain. Want another? Or are you good? Move on? Yeah, okay. Example B. I'm trying to get you familiar with the notation and the different ways that they're going to ask you the questions so you don't get freaked out. So find y prime for y equals square root of u. What's that going to look like?
U to the power of 1/2.
So we can re-express it as u to the 1/2 power, yes? And now what?
Then we can do the same operation, multiply and subtract.
Right, so this is technically a coefficient of 1. Half of 1 simply is a half. U, and I'm going to take away 1, which is technically 2 over 2, isn't it?
Okay.
So this is -1/2. Do we like a negative exponent?
No.
Not really. So we're going to write this as 1 over 2 u to the 1/2, or 1 over 2 square root of 2. We know we don't like square roots, so typically you will correct that by multiplying top and bottom by square root of 2 over square root of 2, and your final answer here will actually result in square root of 2 over 4.
What happened to the u?
Where is the u?
So you go from 1, it's past the or that we lose the u.
I think I wrote this as square root of 2 instead of my mistake. So this is really square root of u. So we're actually multiplying here differently. So scratch that for a minute. So this is actually square root of u over 2u. Oops. Okay. All right, part C. In part C, it's the same process that we continued to practice, which is, in this case, they're asking us to find the d over dx given 1 over cube root of x. Which we can re-express this obviously as 1 over x to the 1/3. And what would be the next step that we should take? We're going to bring this up as a negative, right? So this is really x to the negative 1/3. And now we differentiate. Remember that there's a coefficient of 1 here. So you have 1x to the negative 1/3. So if I multiply, I end up with negative 1/3 x. And if I'm taking away 1, I'm taking away 3 over 3, which, if I write this more neatly, you'll be able to see it better. Give me 1 second. This is really 1 over 3. So that becomes minus 4 over 3. And one more time, we don't really like that. So we're going to re-express this below the fraction bar. So this gives us negative 1/3 cube root under the fraction bar, cube root of x to the 4th power. I don't know if you can see that 3 there. There's a little cube in there.
Yeah.
All right. Obviously, you can also express this as 1 over 3x to the 4/3. Same difference, right? All right, how do you feel about this section so far?
Yeah.
Manageable?
Yeah.
Easy? Yeah. Okay, let's look at theorem 3. So we're looking at theorem 3. This has to do with the constant multiple property. It's so funny, my students that I have during the daytime that are taking calculus are freaking out over this section, and I'm like, come for tutoring, I'll help you. Might as well be talking to a wall. All right, so the theory here is if y is equal to f of x, in theory this is also k times u of x, and then that also transfers to the first derivative of x is equal to the constant u prime x. So they, of course, they show you that also if we're referring to this as y prime, we would say y prime is equal to k times u prime. Or if we're talking about dy over dx, this is equal to the constant times du over dx. So let me show you some examples of that, because that looks to me like alien language.
Gibberish.
It does. It does. It looks. I showed it to a few students, and they were like, "What is that? What language is that?" So let me show you. It's really easy. I just want you to see the connection of how it ties together. So in example 4, we are doing the differentiation. So we're differentiating a constant times a function. Remember what I said to you the first time we met in class, and I said to you, I like making the incomprehensible comprehensible, right? Would you not agree that looks kind of incomprehensible right now?
Yeah.
Yeah, it does. But you actually already know this answer. So watch. So in example A, they're saying find the first derivative for f of x is equal to 3x squared. This is exactly what this theorem talks about. That first derivative is simply 6x. That's what all that means. Yeah, I know, right? Here, let me shrink it so you can look at it again. That's what that means.
Isn't it the same thing as before?
It is.
Wow. Sometimes math can be
So,
I've always said, you know, it's like, make it comprehensible, you know? In part B, they're simply asking the same thing. They say find dy over dt for y is equal to t cubed over 6. Okay, so this is where that function comes in. So what the first thing we're going to do is we're going to separate the t3 and the 1 over 6. Because in theory, this is 1 over 6 times t3. Okay? Now what we're going to do is we're going to take 1 over 6, which is our constant, and multiply it times 3t squared. Remember, there's a 1 here. 3 times 1 is 3. Take away 1 from the exponent. That's where I'm getting 2. And now we just do math. Because technically what I have here is 3t squared over 6, and this reduces to 1/2. So I really have t squared, or 1t squared, over 2. I can also express this as 1/2 t squared. Either way works. Is that okay? Is that okay for you? All right. Let's look at B or C. Slightly the same, just different notation. So they're saying find y prime for y is equal to 1 over 2x to the 4th power. Okay, so based on this theorem, what I'm going to do first is I'm going to separate, in theory, remember this is over a fraction bar, so this is really 1/2 times, I'm going to write this as x to the negative 4 here. I'm multiplying negative 4 times 1/2, which in this case, and I'm also going to take away 1. So I'm going to end up with y1 is equal to negative 2 x to the negative 5th, which I'm going to re-express as negative 2 over x to the positive 5. You want to try one more of these?
sure.
Okay, so let's do it in teal. I'm going to ask you to find y prime for y equals, let's do 2 over 3x to the 5th. Oh, that's going to be ugly. Hang on. Let's make it a 6. Let's make it a pretty number so we can at least work with it. Oh, but this is going to be a 7. Yeah, it'll work. So, I'll give you another minute or two. So again, what is the first thing we're going to do? I would say separate the fraction and re-express this over the fraction bar as x to the negative 6. You with me so far? Okay, so the first thing I did, and by the way, how I got the -2 in case somebody's wondering, it's -4, the original, times 1/2, which is what gives me -2, right? So here, I'm gonna first multiply -6 times 2/3. That's gonna give me -4. And this is times x to the -7, correct?
Yeah.
All right, so what's my final answer?
-4 over x to the 7.
Yeah, -4 over x to the 7th. That's my first derivative. Cool. You want to try another one, or you think you got it? You tell me. You good?
Yes.
All right, part D, or example D. They're going to ask you to find d over dx given 0.4 over the square root of x to the 3rd power. All right, so give this a minute, so let's write it down, and I'm going to talk you through this step by step. So is it really different from what we've done? Not really, because technically this is can you stop that? I see what, I don't know what's happening here. So this is basically d over dx of the constant 0.4 times x to the 3/2 power. So far that's what you have. If you remember, we're going to multiply here this times this and take away 1, which is 2/2. You end up with, in this case, -3/2 times the 0.4 x -3/2 minus 2/2. So technically this is 3 times 4.4 will give you 0.12, divided by 2 is 0.6. So all of this is simply -0.6, and now you have x to the -5/2. But we don't like negative exponents, right? So we re-express this at 0.6 over x to the +5/2. Okay? Are we breathing? We're good? Super. So let's look then at theorem 4, which ties to example 5. If you're ready. Ready? Ready? Okay. So theorem 4. Theorem 4 is another very easy one, and it kind of wraps everything you've learned to this point about differentiation. So it has to do with sum and difference property. So basically adding and subtracting. Sum and difference property. And so we have if y is equal to f of x, which is equal to u of x, plus or minus v of x, then the first derivative is equal to u prime x plus or minus the first derivative, oh my god, sorry, that sucked, of v of x. Same thing applies if I have y prime is equivalent to u prime plus or minus v prime. And another way that this can be expressed is if I have dy over dx, this is equal to du over dx plus or minus dv over dx. Alright, so let me give you some examples of that. I have about 4 of them. And you've already done this, believe it or not. I've already sort of introduced this to you, but I just want you to know that this is what the theorem stands for. If you watch the video and you look at the writing, it'll help the language part of it. Because a lot of this is the interpretation. What does it even mean, right? So, okay, so let's start with example 5. So in example 5, the question says in part A, it says find the first derivative for f of x equal to 3x squared plus 2x. Who can tell me the answer right away? I know all of you can.
Oh, yeah, 6x.
Plus 2. Because remember, this is at least the first power, right? So that's what that theorem says. That's what all that means. You got term A, term B, take the derivative of term A, take the plus or minus depending, and do the derivative of term B. Alright, so let's take a look at part B. Okay, in part B, it says find the first derivative for y equals 4 plus 2x cubed minus 3x to the negative 1. Who wants to answer this one? I hear it.
6x squared minus
Minus or plus?
that'd be plus 3x.
So you can either write this as 3x to the negative 2, or you can re-express this as 6x squared plus 3 over x squared.
Okay.
Either way. Cool. Notice the constant. What was the constant?
4.
After you took the derivative, the constant became
0.
bagel.
Yeah.
Yeah, 0. First thing you learned, right? So part C. The question here says find dy over dw. That is a w. I promise you, it's a dw. Dw for y equals cube root of w minus 3w. Give you a minute on that one. What do you think that answer is? This way? So what do you think this one is?
So that's the cube root of W?
Mm-hmm. What do you think?
1/3 times square root of w minus 3.
Oh, but so close.
Would it be?
Because remember this,
Oh wait, and it's no, but no, it's still you'd still leave the square root because it's 2.
cube root,
You leave the cube root.
cube root. And so the exponents will change.
So it'd be 1/3. 1/3 times the cube root of w minus 3.
You're close.
W squared.
Do I drop?
Who said that?
I dropped the
Yeah, here's the work. So you see the whole thing. So it's dy over dw is equivalent to d over dw, where w is 1/3, right? Because that's what the cube root of that is. minus d over dw of 3w. So we're focusing on these two terms. If you look at this carefully, this multiplies out, so you have w 1/3 becomes 1/3, and this little 1/3 here minus 3 over 3, right? Because we always take away 1. So you end up with 1 over 3 times w to the negative 2 over 3, which we always correct by dropping it below the fraction bar. So this is 1 over 3 w to the 2/3, at least for the first term. For the second term, technically, it's 3w to the 1 power. So 3w to the 1 power. 1 times 3w, or 1 times 3 is just, it's technically minus 3. And then here's your w to the first minus 1,
Which is 0.
which becomes 0, exactly. And that's your final answer. Super.
Okay.
Okay, I'm gonna give you this next one as well. This is part D, and part D says basically find d over dx given 5 over 3x squared minus 2 over x to the 4th plus x cubed over 9. Right, so I'll give you a chance to attack that one. All right. So let me express these and just highlight some things for you to help you see it a little bit more clearly. So see the 5/3?
Yeah.
See the 2? And technically this is 1/9 in theory, right? So what you want to do is you want to express this as 5 over 3 times x to the negative 2, right? Because we're going to bring this up. And you should always do the d over dx as a process, because this is technically being done as such. So this is minus d over dx. And this would separate, so you would have 2, technically, and this becomes times x to the negative 4. Does that make sense?
Yeah.
And then lastly, on this one, plus d over dx of 1/9, and this is times x to the third power. So if you can just sort of mentally start separating that way, it's just a process. All right, and so if I multiply this, this becomes 5/3 times -2/1, technically, right?
Mm-hmm.
And this is times x to the -3, because I'm going to take away 1, so x -3, minus, this is 2 times the -4. I'm going to take away 1, so this becomes times x to the -5, plus the 1/9 times, and again, remember this is times x to the third, which I'm differentiating to be 3x squared. You already know how to do that. So now you just distribute accordingly, so your final answer here will be -10 over x to the +3, right? Because you want to, I'm sorry, I forgot the 3. -2 times 5 is -10, and then over 3, and then x to the +3, because we always correct that. So that's all of this. All of this is that. -4 times -2 is +8. And since this is x to the -5th, it drops down as x to the +5th. And I'm going to finish here with 1/3, so plus 1/3, because this becomes 3/9, hence 1/3. And this is just x squared because it's already positive, so. This is the first derivative of this expression. All of that. Shall we do another? See?
I got the second and the third part correct, and I messed up on the first part. So this is good.
So as you practice these, you'll start to see the connections. All right, if you're ready, I'll give you another one. So we're gonna I'll do this in teal. So this will be, let's call it practice E. So we're gonna find d over dx. And we have seven over 4x squared. Let's go with plus 3 over x to the 5th minus, let's do x squared over, I don't want to do 9 again, let's do another number, let's do, got a 5, let's do 5. All right, try that one, see how you fare. Have about another minute. All right, are you ready? So what's the first thing that we should consider?
First term will be 7/4 times x to the -2.
7 over 4 times x to the negative 2 power.
Mm-hmm.
Okay, plus
3 times x to the -5.
3 times x to the negative 5th, because we're bringing it up, minus 1/5
Times x.
times x squared, in theory, right?
Right.
So negative 2 times 7 over 4, negative 14 over 4, x to the negative 3rd, correct?
Yeah.
That's the first step. Minus 15 x to the negative 6, because I'm taking away 1 on the exponent after I multiply. And this is minus 2 over 5 x, because I take away 1, right? So it becomes... Last step, I'm going to reduce this. So this becomes negative 7 over 2 x to the positive 3 minus 15 over x to the positive 6, and then this is just minus 2/5 x, and that's the first derivative of that function. Easy?
I have a
Awesome.
question.
Yeah.
So does the x on the last part, can that be on top or can
It is on top.
okay.
Because it's positive, it stays on top, and it remains positive because 2 minus 1 is just 1. So it's just sitting there.
Does it matter if you have it on top or on the side?
Oh, you mean like 2x over 5?
Yeah.
I don't think it would matter.
Okay.
Okay, I think so far so good, right? And let's look at example 6. If you're okay with this one. Remember, this is on the recording, so you can always look back on it. So here's example 6. This is the process of rewriting before you differentiate. And it's a simple one example. So they're saying here, find f prime x, the first derivative, given 1 plus x squared over x to the 4th. And what they mean by rewriting is, you notice how this is a shared denominator, right? So you're going to spread it out so that this is 1 over x to the 4th plus x squared over x to the 4th. And so that's the first step you're going to take. The second step you would want to take after this is, for example, this is x to the positive 4 here. I'm going to bring it up as x to the negative 4 plus, and then I'm also going to reduce this top to bottom. So this is actually re-expressed as 1 over x squared, which I also will bring up as a negative. So technically, my current equation is x to the negative 4 plus x to the negative 2. Now we differentiate. So remember the coefficient of 1 in front of both of these. So this is really negative 4. And I'm going to take away an exponent. So I should have negative 4x. Why am I brain farting? X negative 5, minus 2x to the negative 3. and I re-express this as well. So this is negative 4 over x to the positive 5 minus 2 over x to the positive 3. That's all they're asking you to do for that one. So when they say rewrite, don't panic. All they're saying is move the value. Okay, example 7 has to do with instantaneous velocity of an object. So it's an application question, and it's actually very simple. I only have 2 examples remaining. So example 7, instantaneous velocity and so the question says an object moves along the y-axis in the question. It says it's marked in feet so that its position at time x in seconds is, and they're giving you the equation x cubed. So f of x, the displacement function, is x cubed minus 6x squared plus 9x. So that is the question, or at least the setup. Question stem A says find the instantaneous velocity. So make a note mentally of the question stem and what we're going to do. So we're finding the instantaneous velocity of the function. So they're giving us where f of x, so we're looking for f prime x, which in this case is going to be what? So velocity is going to be 3x squared minus 12x plus 9. So remember displacement. So if I said to you, remember, if you're going to remember the acronym, it's DVA. So displacement is the original f of x. Velocity is the original derivative. And then acceleration is your second derivative. So that's all you need for that. This is, I missed one word here. Right after velocity, they just want the function, which is what we have. They didn't ask us for a value yet. In part B, they're saying find the velocity at x is 2, at x is 2 and at x equals 5 seconds. So this is 2 seconds, this is 5 seconds. So that's where this part A comes in, because we're going to say basically the first derivative at 2, where x is 2, is equal to 3 times 2 squared minus 12 times 2 plus 9. And I believe that means that we're going to drop 3 feet per second at this point. The second part of the question is we're checking it at f first derivative of 5. So we're going to say this is equivalent to 3 parentheses 5 squared minus 12 times 5 plus 9, and this is equal to 24 feet per second. Easy so far? And part C, the last part is even easier because you've already learned how to FOIL, right? And so if we take our value, and since we're looking at, it's saying find the time when the velocity equals 0 or is 0. So basically we're going to take that first derivative, which is 3x squared minus 12x plus 9, and we're going to set it to 0 because the first derivative is velocity, right? So if I take out a 3, which is common in all three terms, I get x squared minus 4x plus 3, right? And this is equal to 0. And if I factor this further, this is basically x minus 3 times x minus 1. So the values, or the time, in this case, when the velocity is 0, is at x equal to 1 or 3. And all you got to do is set them to 0 and solve. Super easy. All right. And the last example coming up, tangents. Okay. So this has to do with the secant line, the tangent line, and values where we have a horizontal tangent line. So this is actually very easy. And this is example 8. All about the tangents. And so they're giving us let f of x equal to x to the 4th minus 6x squared plus 10. And so part A in the questions is only parts A, B, and C. Part A says find the first derivative, which we know helps us find the slope of the tangent line. And so this is going to become 4x cubed minus 12x, and that's all it is. Easy. And part B, they want us to find the equation of the tangent line at x equals 1. At x equals 1, that means that we have 1 to the 4th power minus 6 times 1 to the 2nd power plus 10. So that's 1 minus 6 plus 10. That gives us 5. Using the first derivative, because remember this is f of x, and this is the first derivative, which is going to give us 4 times 1 cubed minus 12 times 1, and that gives us negative 8. So now we can use not the slope-intercept, but the point-slope formula. Thank you. So we're going to say in this case y minus 5 is equal to negative 8 times x minus 1. Since we already knew x was equal to 1, that's what helps us here, right? This gives us the slope, and this gives us one of the y's. And so doing a little math, we know that we have y minus 5 is equal to negative 8x plus 8. And if I add the 5 to both sides, I have the equation, which is y equals negative 8x plus 13. Done. Now, because the first derivative tells us the slope of that tangent line, we're going to use that in part C, where it says find the values of x where the tangent line is horizontal. And I've said this a few times in class, that if that tangent line or any line is horizontal, that slope is 0. So we're going to take that slope formula, or that first derivative formula I should say, and we're going to say, well, that's 4x cubed minus 12x has to equal 0. If I extract what is common to both terms, I get 4x, leaving me x squared minus 3 is equal to 0. So technically, this is a repeating 0. So I know that one of my solutions is x equals 0. And the other solution is that I know x squared minus 3 equals 0. So x squared is equal to positive 3. And x is equal to plus or minus the square root of 3. And so these three are my solution set. My solution set is 0, comma, plus or minus square root of 3. Okay, okay? All right, Artichoke. Your homework and quizzes are already ready for you on Pearson. So I'll see you Monday.
Yep.
And I'll have the recording up as soon as it renders.